Okay, so I want to talk a little bit today about angles. In the past, we have measured angles most of the time in degrees, which really just measures the direction and the angle size. And you guys have, probably dealt with degrees before. If you measure an angle and it's got 90 degrees, we know that to be a right angle, which means it's perpendicular, and so on. So what we've done in the past is measured degrees. Angles, specifically, can be measured in a positive or negative angle. And you might ask yourself, how in the heck can you have a negative angle? Well, it really just indicates the direction of the rotation of the angle, and I'll show you what I mean here in the examples down here below. Positive angles, whoops, too far. Positive angles result from a counterclockwise rotation. And negative angles, therefore, would result in a clockwise rotation. And if I were to start at one point, if you kind of think about a clock, if you were to start at one point on a clock and go all the way around back to that exact same minute on the clock, that is a full rotation, a complete rotation, which is measured as 360 degrees. All right, so let's take a look at what we've got here so you can kind of get the idea behind a positive and a negative rotation. If you look at this first example, letter A, we started right here where the blue dot is, and we have measured the angle following this little arc that way. That is a counterclockwise rotation, and it is a measurement of positive 150 degrees going in that direction. If we look at the one I'm going to draw in green here, letter B, if I start at the dot there in green and I go the other direction in a clockwise rotation, the same way the clock's hands would move, that is actually considered a negative angle because it's going the opposite direction. So it's, again, think about a clock. It's like taking the hands of a clock. If you put the hands and went backwards on a clock, that would actually be counterclockwise. That's actually considered a positive angle. Going clockwise is considered a negative angle. And the degree measures we'll worry about later, but you can see how that would work. All right, so how do we actually figure out where do we start, where do we finish, all that kind of stuff? Well, rotation is measured from the initial side, which is your starting point. So in this case, we started here. That's the start, or the initial side. Okay, very much like over here. This one right here was the initial side. And we keep going, we keep rotating until we hit what is called the terminal side. Terminal. Terminal meaning to finish or to stop or to end. Terminal side. And that's what this is right here. That's the terminal side. Same thing over here. An angle that has its initial side on what is considered to be the positive x-axis is called to be in standard position. So again, let me kind of tell you what I mean by that. So if you were to take and draw, let's do this in, used all the colors, just go ahead and do it in black. If we were to kind of draw an XY axis through one of these, I'm only going to do it for one of them. If you say that this is the y-axis and this is your x-axis, well, now you can see how the positive x-axis right here, this piece right here, this is the positive x-axis, you can see that this initial side started on the positive x-axis. And if that's the case, that's what is called standard position. Two angles which happen to share a terminal side are what are called coterminal angles. Coterminal. Co meaning both at the same time, and then terminal meaning that they're going to end at the same place. That is supposed to be an A. Coterminal angles. So again, what does that mean? Let me kind of use the letter A here to show you what I mean by that. You can see that if I went in the counterclockwise rotation, I got an angle of 150 degrees. If a full rotation is 360 degrees, if I went backwards, if I went this direction, but yet I ended at exactly the same side, well, that's what's called a coterminal angle. And in this case, since I went in the clockwise fashion, it's going to be a negative angle, and it would actually be negative 210 degrees in that direction. Those would be considered coterminal angles because they finish in the same side. And the one thing about coterminal angles is there are infinite number of coterminal angles, because nothing says that I have to stop there. I could keep rotating further and further and further, making multiple circles, and then eventually stop there again. So again, we'll talk about that more in depth. All right, so here's a good example. Given that the angle shown is 120 degrees, now because it is a positive value, I know that it started at the positive x-axis and went up to here in a counterclockwise fashion. That's 120 degrees. Label the initial side. Well, the initial side is the positive x-axis. So that's your initial. And the terminal side is where it stops. That's this piece right here. And we want to determine the measure. Now this says of the coterminal angle. That's actually very badly worded because there are an infinite number of them. So we'll say of a coterminal angle. The one that they're intending us to do here is the negative angle within the circle. So what they want us to find is this angle right here. Well, if we know that the entire circle is 360 degrees, and I know that the piece up here, which was my positive angle, is 120, then really all I have to do is subtraction. 360 degrees, I'm sorry, yeah, minus the 120 would give us 240 degrees. But that 240 degrees went in the clockwise direction, so it actually needs to be a negative 240 degrees. That would be the coterminal angle there. Is the angle in standard position? Yes, it is in standard position because the initial side is on the positive x-axis. Or at least we could create it so that it is. Okay, hopefully that makes sense. Number 2, if an angle measures 390 degrees, where does the terminal side lie? And it's going to ask us about quadrants, and we'll talk about all that stuff here in a second. Whoops, keep doing that. Here we go. So if an angle measures 390 degrees, where does the terminal side lie? So let's go ahead and put in our initial side. Okay, we're going to go like here. Positive x-axis will be our initial side. If it rotates 390 degrees, now think about that. A full circle is 360 degrees, and it's positive direction, so it's going to go all the way around 360, and then it's got to go a little bit more. It's got to go another 30 degrees in that direction. So here, is your terminal side. Well, it went a full 360 and then it went an additional 30 degrees in this direction right here. So it says, in what quadrant does the angle lie? Well, this goes back to your standard being able to graph or plot points on a graph. Again, remember, the idea is if this thing creates a positive, a quadrant plane, and the initial side is on the positive x-axis, and here's your y-axis. Remember that your quadrants start on the upper right, and that's quadrant 1, and then they go counterclockwise. That's quadrant 2, quadrant 3, and quadrant 4. So in this case, the terminal side of the angle 390 degrees actually lies right here in quadrant 1. And then it says determine a negative coterminal angle for that particular side. Well, a negative coterminal angle would be starting here and going this direction, but I can stop right there. So if this angle in here is 30 degrees, then that means that the coterminal angle, if I start at the initial side that I started off at, is 360 minus 30. Which is going to be 330 degrees. But again, it went backwards, so it is a negative value. So it's negative 330 degrees. Okay, hopefully that is making sense. All right, number 3 says find positive coterminal angles that are within one rotation of the unit circle. 0 is less than or equal to degrees, which is less than or equal to 360. Basically, it's saying just go within one 360 degree rotation. We don't want to go to 390. That's after one full rotation of a circle. So if I'm going to find a coterminal angle, and they've given me a negative number, well, that would be a backwards rotation. In order to get it to a positive number, I'm going to have to add values to it. Well, if I want to get a value that's in the same place, if we think about this, if we have a circle, and here's my positive axis. I'm going to erase this in a second, but you can copy it if you want to. If I went negative 45 degrees, it's going to go that direction, 45 degrees. So this is where the angle would be. If I want to get right back around to this exact same place right here, if I want to go in the positive direction, I need to go all the way around the circle one full time to get right back to that. Well, one full rotation is 360 degrees. So in order for me to get, let's see, eraser. There we go. In order for me to get from negative 45, in order for me to get from negative 45 into the positive rotation, I have to add 360 degrees to get right back to exactly the same place. And that's going to be the same with everything. If I want to get to a coterminal angle from a given angle, all you have to do is add or subtract 360 degrees every single time. So in this case, I'm just going to take negative 45 degrees, and I'm going to add 360 degrees. And that's going to give me, what is that, 315? And 315 is in between 0 and 360, so we're good. In letter B, they've given me an angle which is way bigger than 360. 750 degrees is definitely a bigger angle than 360. So in this case, to get between 0 and 360, we would now have to be subtracting angles. So we're going to start subtracting 360 degrees and see what that gets us. So 750 minus 360 is going to be, what is that, 390? Yeah. But 390, again, is outside of 0 to 360, so we need to do it again. We need to subtract another 360. And when I do that, we end up with 30 degrees. And 30 degrees, again, is in between 0 and 360. So that's how you would find a coterminal angle within one rotation of a unit circle, and this, we'll talk about exactly what that means in a few minutes. Okay, finding coterminal angles, not too difficult to do. Adding and subtracting 360 if necessary, probably the easiest way to do it. And then keep doing it until you get to within the range that they're asking for. All right. So now that we're done talking, well, not completely done, but now that we've talked about degrees, which is what most people have measured radians in, excuse me, what most people have measured angles in up to this point, there's another way to measure angles, okay, and it's called a radian. It's this thing right here. Whoops. Let's erase that. So that's that thing right there. It's called a radian. So what we've talked about so far is everything that has been measured in degrees. It's highly unlikely up to this point that you've seen anything other than that. A radian is another unit of measure of an angle. It actually has a slightly different meaning, but it's another way to measure an angle. Radians actually relate to the arc length and involve, this is long, so I'm going to write it down here, a special relationship, with pi. So there is a special relationship that these angles have with the letter pi, the number pi, excuse me. All right, so this is the best way I can describe it. If you think of yourself as being a person which is standing right here, and you have somebody over here which is walking in a straight line, so they're walking in this direction. In order for you to follow their path, you're going to either have to swivel your head or you're going to have to change the direction of your eyes. You're going to have to follow them in some fashion. What's happening is, if you were to actually turn your head along with the person walking, this thing right here, that angle that you turn your head, the amount of distance that you're turning your head there creates the degree. So the tilt that your head goes through is actually the degree that this person is creating for that angle. The distance that the person actually walks is actually going to be the radian. So this part right here amounts to what's ultimately going to be considered the radian. So it's the same measure of the same angle, but it's done in distance traveled as opposed to the tilt. So that's, it's not the best example, but it is something that we can go off of. Okay, so how are we going to relate radians to degrees? Because that'll help us to get, to wrap our heads around what this thing is actually talking about. So what we want to do is we want to consider a circle that has a radius of 1. All right, first of all, this circle with a radius of 1 is what is considered a unit circle. So we're going to put that over here. A unit circle is a circle with radius 1. And the fact that they call it a unit circle is because the radius is 1. 1 indicates a single unit of measurement. So that's what's called the unit circle. It's because it's got a radius of 1. All right, so what is the circumference? Well, we have to remind ourselves the circumference formula. Circumference of a circle is 2 times pi times the radius. And if the radius is 1, so if r equals 1, then the circumference is 2 times pi times 1, or just simply 2 pi. and that is the circumference of an entire circle if the radius is 1. So the idea is, suppose that instead of walking straight across like the back of a classroom like we saw up here on this example right here, so instead of walking straight, now let's say this person is going to walk a circle in a circular rotation, keeping the distance of 1 constantly, which is obviously very difficult to do, around us. So if you kind of look at the diagram here, if student B were to start walking, and I'm going to change it from here, if they were to start walking from there, and they started walking up here, and that, oops, let's do a different color, you can't see that one, here, and then they walked up here, whatever that distance is that they're covering, that's the radian. The angle that our head tilts to get from here to here is the degree. Okay, now how does all this stuff relate, and why did I give you this whole circumference equals 2 pi thing? What does all that stuff mean? Well, if you think about it, if the person walked completely around the circle, all the way around, starting from where I put the dot all the way back around to the dot, the rotation that student A's head would have to move is in a 360 degrees, because it would have to rotate the entire circle. The distance that the actual student travels, however, is the radian, and because they went the entire circle, and we know that the entire circle, I wish it would stop doing that, we know the entire circle has a circumference of 2 pi, they've actually walked a distance of 2 pi. So ultimately, what we're going to end up with is that the fact that 360 degrees, or the conclusion here, is that 360 degrees is the same as 2 pi radians. Okay, and that's an extremely important concept when it comes to trig, and that's pretty much what we're going to be starting by going through this unit. Whoops. All right, but here's a really good question. So I've kind of told you that a radian is some kind of a measurement, and how it relates to a full circle is that 360 degrees equals 2 pi. But what the heck is a radian? I mean, what really is it? What is a radian? Well, here's the simplest idea for what a radian is. Let's go ahead and erase this. So a radian is, this is what you have to think about, and there's no coincidence that the word radian sounds kind of like the word radius, because they are related extremely well. If I took and measured the radius of this circle, now the measure of that radius of that circle is 1. If I take that and I were to say, okay, if I took the same distance that that radius is, and I started here and I started to walk so that my distance around the circle was exactly the same as the radius. Why is that not showing up? There we go. So my distance around the circle is exactly the same as the radius. Well, this distance right here, from here to here, would actually be 1 radian, because the distance from this point, we'll call it point A, to point B, is exactly the same distance traveled that you would travel from this point A to out here. Should have used something other than A, I guess. Well, let's see how this works. If we keep going, now maybe I'm going to start at point B, and I'm going to walk another radian, which means I'm going to walk the same distance as the radius, but I'm going to do it around the outside of the circle. So maybe that's about right there. And I'm just kind of guessing. But that's another radian. So the total distance now from A to, we'll call this C, would be 2 radians. And then, I haven't used red yet, if I walk from point C, the same distance, all the way around to here, and it's going to stop right about there, well, that would now be 3 radians. What you should notice, because I didn't finish it, is that if I went backwards from A out to here, that would be halfway around the circle. Well, I've gone 1, 2, 3 radians to get to this point right here. We should realize that if the full circle is 2 pi, then half of a circle would relate to pi radians. And if you remember, pi is approximately equal to 3.14159 and so on. Well, I've gone 1, 2, 3 radians. If I get all the way back around to here, that is 3.14159 and so on. That is pi radians. So that extra little distance right there is the difference between pi and 3. So that's what a radian actually is. It is the same measured distance of the radius around the outside of the circle. And it will work for any circle. If this was a 5 radius right here, then you would have to walk 5 to get to B, 5 to get to C, 5 to get to the end of the red, and it would still work out that the whole way around, the halfway around this thing is pi, all the way around is 2 pi. It will always work that way. Now let's get rid of that 5 because it's really not supposed to be there. All right, and I've gotten ahead of myself just a little bit, but now if you think about it, we just answered the question. So an angle measuring 180 degrees, so 180 degrees would be this direction on the inside, we now know is pi radians. And how do we get that? Well, if we know that the full thing is 360, 360 is the same as 2 pi. Well, if I'm going to get 180, I'm going to divide by 2. So I'm also going to divide the radians by 2, which means that what we would get is 180 degrees is pi radians. And I did answer that up in the previous problem. So 180 degrees is pi radians. Okay, this is probably the key right here. This is the most important one because we'll use that one mostly. 180 degrees is equivalent to pi radians. This is kind of how we're going to be able to convert back and forth between degrees and radians for things which are not so easy to figure out. Okay, what we can figure out is how we would get 90 degrees. Well, if we know that 90 is half of 180, so once again I would take 90, I would take 180 and divide it by 2 to get 90. Well, that means I would take pi, because pi is equivalent to 180, and also divide it by 2. So what we say is that 90 degrees is equivalent to pi over 2, or pi halves. You can also write it as 1/2 pi, but most commonly it is written this way, pi over 2, pi halves. And then you could keep going. We could figure out more special angles. If I wanted to find out what 45 degrees is, I would take 90 and divide it by 2. I would take pi halves and divide it by 2, and so on. And we're going to be able to do that kind of stuff later. So ultimately, all this has been building up to, how do we get back and forth easily between degrees and radians? How would I figure out how to do that? Well, there is a formula that you can use to do that. I prefer not to use it, but you can. I'm going to give it to you anyway. And then I'll kind of show you the easier way. If I want to convert from degrees to radians, you're simply going to multiply whatever your degrees are by pi over 180. And that'll convert from degrees to a radian. Then if I wanted to go backwards, maybe they gave me the radian instead and I want to get to degrees, well then I would multiply by 180 over pi. Now, you should be able to look at that and think, okay, that's going to get confusing. I'm going to mess that up somewhere. There's almost no chance I'm going to remember which one is which, or I might mix them up, and that's going to happen. It's okay. Let me show you a different way to think about this, because this is the way I prefer to do it. If you remember the relationship, and this is why I said that this is important, that pi is the same as 180. And you can do this in two different ways. Matter of fact, let's change that. We'll do it like this. Pi is equivalent to 180. So that ratio right there is 1. Pi over 180 basically is 1. If I remember that this is the case, I can solve any one of these problems by doing a basic cross multiplication, because what I'm going to do is I'm going to set up a proportion. Pi over 180 is the same thing as, well, pi is a radian and 180 is a degree. If I remember that that's the case, if they give me the radian, I plug it in here, and then I cross multiply and solve for d. If they give me the degree, I plug it in there, and then I cross multiply and I solve for r. It's easier to do it that way than remembering which one of these formulas I have to use and when, at least as far as I'm concerned. So let me show you what I mean. Let's do the example down here at the bottom, number 1. They gave me a degree. So the first thing I'm going to write is I'm going to write my proportion that pi over 180 is the same as the radian over the degree. They gave me the degree. I'm going to plug that in for d, and then I'm going to cross multiply and divide. So I'm going to set this up as pi over 180 equals the radian, that's what I'm looking for, over 255. If we now cross multiply, we'll get 255 pi equals 180 times r. I'm solving for r. I want the radian. So what do I have to do? I have to divide both sides by 180. So bringing this stuff up here, ultimately the 180s cancel out. I'm going to get r equals 255 pi over 180. Now it is good that if you could reduce these things to go ahead and do so. Let's see, 255 over 180. If you can't think about this stuff real easily in your head, do it in pieces. You should know that they both end in a 5 or 0, so 5 goes into both of them. Looks like I'm going to get, what is that, 51 over 5 goes into 180 36 times. And then don't forget your times pi. I think 51 over 36 is still divisible. Yes, it is, because 51 is divisible by 3, and so is 36. So this can reduce even more. 51 is 17 over 12, so 17/12 pi. Now, was this answer wrong? No, it's still right, it's just not reduced. And technically, you could have left this as your answer, and it is still correct, it's just not reduced. We need to get in the habit of reducing these things, though. All right, let me do one more with degrees, and then I'll do one with radians, and then the rest of these will be up to you guys to try and figure out. Okay, so pi over 180 equals the radian over the degree. Well, they gave me the degree, so I'm going to plug that in for d. So pi over 180 equals r over 15. Cross multiply, 15 pi equals 180 r. Divide both sides by 180. So we're going to get that r equals 15, that's a 180. 15 pi over 180. 15 actually goes into 180. I just happen to know that. You might not know that. But 15 goes into 180. So it goes into 15 once. It goes into here 12 times. So I'm going to get 1 pi over 12. That is the radian measure that is equivalent to 15 degrees. All right, let me do number 3, and then the rest of these will be up to you guys. Let me change colors there. So this time they've given me a radian. How do I know it's a radian? That's a really good question, because there's no degree symbol. So it doesn't have to have a pi in it, although most of them will, but it doesn't have to have a pi in it to be a radian. But if it doesn't have a degree symbol, it's a radian. So once again, it is pi over 180 equals radian over degree. This time I'm going to plug in 2 pi over 3 for the r. So pi over 180 equals 2 pi thirds over d. We're still going to cross multiply. Trust me, we want to get rid of this big old messy fraction on the right anyway. So what we get is pi d equals 2/3 pi times 180. Okay, now you do have to be able to simplify this because otherwise dividing by pi is going to leave it unsimplified. So you have to be able to multiply 2/3 times 180. Well, you could multiply 2 times 180 and then divide it by 3, or you could choose to divide the 180 by 3 first and then multiply it by 2. It doesn't matter. Order of multiplication and division is commutative. As long as you do it in the proper manner, it's fine. So I think I'm going to divide the 3 by 180. So that's going to give us 60. Right? 180 divided by 3 is 60. So then 2 pi times 60 is 120. So I'm going to get pi d equals 120 pi. And then to solve for the degrees, I'm going to divide by pi on both sides. And I get that the degree measure is 120 degrees. So 2 pi thirds is equivalent to 120 degrees. And as you go higher in math, that's one angle that you're going to know, and we'll actually know that one later on in this course, but that's an angle that you're going to have to know pretty quickly. It's it's considered a special angle on the unit circle, and it'll be helpful to know that one. Okay, so you guys have a few examples left here. You can go through on your own, 4, 5, and 6, see if you can do the conversions, and we should be good.